time for another DraftPhysics.com, DebatePhysics.com also. But as stated,
debate? Are you fucking kidding me?
the debate lacks any coherency in the sense of argument, counter-argument. So I'll just make these arguments again.
No, there isn't just counter-arguments coming your way. There's counter-evidence to support those arguments, isn't there? Physical evidence that you can't handle.
And say, come on, either be honest or to hell with you.
A little bit of projection there.
So what they're claiming is that the law of the lever isn't true. So this 2000...
Nobody is claiming that the law of the lever isn't true. It is true. You just strawman the arguments.
1,000-year-old theory that the distance is proportional, completely proportional, to what you could argue would be the capacity.
The distance is completely proportional. What kind of ambiguous statement is that?
Of something to balance or, in the case...
Balance, yes. Think about that.
Case of representing a change in the direction of the energy, and that's what levers do. Okay, you put a force.
If it's balancing, how is it changing direction?
In one way, you get a force back the other way, basically. And there's a lifting force. You put in a pushing force down, you get a lifting force.
Yeah, but if you pushed it, you just said if you push it down, so you'd be adding more force then, wouldn't you?
Force up, blah, blah, blah. And the argument is if you're at the same distance, okay, from a fulcrum, that it's equal. And if you change that distance or you change the mass ratio based on distance, that you'll be able to create an equality. So,
yeah, if you change masses and distances, you can get an equality, yes.
The case I did a 4-to-1 relationship, but in this case we'll just do a 2 mass here would be the same as a 1 mass here. They would weigh the same, so it would balance.
Right, how are they weighing the same? You've just said we've got a 2 mass and a 1 mass. So how do they weigh the same? They don't weigh the same, do they?
Balance. Gravity would give them the same momentum into the lever.
If they're balancing on the lever and they're not moving, where's momentum in all this? They're not moving.
And produce an equality, stating basically that these two objects weigh the same, even though their masses are very different.
So you acknowledge that the masses are different, yet they weigh the same, but one's twice as massive as the other. So they don't weigh the same, do they?
Because of the forces are essentially equal.
No, the forces aren't equal. That's a 1 mass and that's a 2 mass. So that 2 mass has got twice the force of that 1 mass. So the forces aren't equal, are they?
Being applied against each other in this manner. Okay, where you change the distance from a fulcrum. And
there we go, distance, which is the law of the lever, force times distance. So, as I've just said there, we've got a 2 mass, so that's got 2 units of force, and it's 1 unit of distance. Force times distance, 2 times 1 is 2. And then on the other side, we've got 1 unit of force at 2 times the distance. 1 times 2 is 2. 2 and 2 is equal, and therefore it balances.
Obviously, I'm arguing the distance from the fulcrum really just means and just represents a distance, and it just represents the fact that this will move twice as much as this will.
But again, it wouldn't be moving, would it? It'd be balancing. If you add something to it, the whole system moves as one. It doesn't, you could put something, you could balance it with 10 times the mass, 10 times further out, and so on, and move it, and it becoming 10 times as fast, but it wouldn't move. It would just balance unless you add something to it, and then the whole system will move as one, And of course, yes, it makes no difference. You could put fucking 30 times further out and so on. But ultimately, it would just stay there and balance.
Move in the same time. So all you're doing is changing the velocity. So a 2 mass at 1 velocity equals a 1 mass at 2 velocity. Now,
oh dear.
they're claiming, all right, so the law of the lever was basically just say mass times distance. So 2 distance.
No, not mass times distance. Force times distance. The mass gets the force, obviously, from gravity, because that's where the force is coming from gravity. You've got the mass, which you've got gravity accelerating, and that is equal to the force.
Distances times the same mass, 1 distance times the mass. Those are equalities. They're saying that doesn't happen. That I put the 2 mass in with 1 velocity, and I only get a 1 mass going 1.4. Now,
right, who says that apart from you? Nobody's making that argument except you.
obviously the inverse of that is I put the 1.4 1 mass in, and I get a 2 mass going 1v out, which is increasing the momentum. Now, in the case of the 4-to-1,
and again, nobody's saying that. You find a quote from a teacher, a physicist, a quote out of a textbook where somebody claims that happens, because that would violate the conservation of angular momentum, and I don't think anybody educated in physics would claim that, apart from yourself, who's not educated, obviously.
Relationship, which is easy to do, it's exactly double the momentum. So they're saying that I can put 100 momentums in, okay, to this. Let's just say we turn this into a box, this whole experiment.
What?
And we just have a mass going in, a 1 mass with 100 momentum. Their argument is...
A 1 mass with 100
My argument is, let's put it that way, is that I can use a lever to convert that into a 4 mass going 1V.
Right.
I have a
Really?
1 mass going 4V here that equals 100. I can convert it into a 4 mass going 1V, and then I can change that direction in the sense I can use a second lever.
Oh, right, okay.
Okay, and just do another 4 mass at 1V, changing the direction, and that's what I'll get out. So I'll get a 4 mass going 1 velocity going the same direction.
So you just drew a complete thought experiment there. You say, oh, this is what I'll get. Obviously, not an experiment. You just made it up, and now you seem concerned with direction. Interesting.
So I have doubled the momentums, and I have 200 momentums going in the same...
But you haven't doubled anything, have you? You haven't actually done anything there. You've claimed something by drawing it. You know, that's not an experiment. That's not, try it physically. You're saying this will be the end result. Good luck with that one.
Same direction. I don't have anything going the other way. There's nothing going the other way. There's no counterbalancing anything. There's just an increase in the momentum, period. So anyway, on its face, though, I think most people would say...
So yeah, you just made that bullshit up. Okay.
Okay, a 1 mass going 1.4 velocity, that is only 0.4 faster, is not going to produce a 2 mass at 1V. Just... No.
Correct. And nobody's claiming that except you. You're strawmanning the arguments, saying that that's what physics claims. No, it doesn't. And again, provide evidence. If you're making that claim that that's what physics says, then you provide evidence to support what you're saying. Because I think you'll be very fucking looking a very long time to find that.
Not going to happen. I think your life experience says it's not going to happen. They're claiming their physics says it absolutely does happen.
No, nobody's claiming that. Nobody says it absolutely happens, because like I say, that would actually violate the conservation of angular momentum. So nobody's saying that except you.